Hello, Physics 1. Welcome back. Let's do a cross product. Doing a cross product. I've been sitting in a room by myself too long. We're going to do cross products with vectors. Bam. All right, so I have talked about IJK notation before. And these are three special unit vectors. I'm going to show you a couple of different ways to go about doing a cross product. It actually doesn't matter which one you use. I will tell you which one most students find the easiest to do. But you need to discern that for yourself. So I is the unit vector corresponding to the x plane. J is the unit vector corresponding to the y plane, and k is the unit vector corresponding to the z plane. All right. And they've got some interesting properties. So I cross k, oops, it would help if I wrote this out correctly. I cross j is equal to k hat. J cross I is equal to minus k hat. J cross k is equal to I hat. K cross j is equal to minus I hat. K cross I is equal to j hat. And I cross k is equal to minus j hat. All right, so already we can see one property of cross products. Order matters. I cross j is not the same thing as j cross I. And after you learn how to do this, prove this to yourself. One of the best ways to get comfortable doing cross products is to do them. These are really easy vectors to start with. I mean, there's zeros and ones. I was writing binary for a reason. All right, so I'm going to teach you a little trick to cross products. By the way, I used this way of doing cross products through my first year and a half of doing physics until I kind of just had the form memorized. Actually, not only did I do that, nearly every single one of my peers did that because it's just a really easy way to not get tangled up. So I'm going to teach you a trick. Okay, so we're going to have two vectors, A and B. A is equal to AX, AY, AZ. B is equal to BX, BY, BZ. Yeah? All right, so we can line them up. I, J, K, I, J. And then underneath each of these, you want to start with A on top because we're going to calculate A cross B. So that means A goes on the top row, B goes on the second row. So you have AX, AY, AZ, and then you have another I here, so that's AX, AY. Okay, now we do the same for B. So I corresponds to X, so we have BX, J corresponds to Y, BY, K corresponds to Z, BZ, I, X again, BX, BY. All right, so we want to go after A cross B. To get what's in our X component, we can take Y, and the first thing we want to do is we want to start with our first I here. So then we go down, and we see this line goes through AY and BZ. So then we have AY, BZ, minus, let's go to our next side. Now we're going to go in this direction. And we see that we go through AZ, BY. So AZ, BY, and that's our X component of our cross product, comma. Now we need the Y component. J corresponds to Y. So we draw down, go through AZ and BX. So we have AZ, BX minus, go down again. Now we have a X, B, Z. And we're done with our Y. Now, Z can be, it's not really that tricky. Basically, you've got this 1K in the middle. So first you need to go to the right, just like we have been doing. So we see we go through AX and BY. So AX, BY, once again a minus sign. Down again, AY, BX. And that is your cross product form. So I really recommend using the IJK method if you've never done a cross product before. It is a way that you can just double check yourself. Also, it's really easy for me to check your work if something has gone wrong with your cross product. So when you do cross products on tests and quizzes, I want to see your work. If you just give me a final vector as an answer, I will not give you all the points. I want to see how you've done it. So either one of these works. So this is the cross product formula that we just derived here. And this is so you can either learn the cross product formula through memorization, or you can use the IJK method. It doesn't matter to me. I just really recommend this one because students often find it to be a lot easier, and it because you've written it out so clearly and you can check yourself so easily, I find the margin for error is a lot smaller. Or sorry, the margin for error is it is a lot smaller. That is the word I'm looking for. Okay, so let's practice. What is 2, 3, 4 crossed with 5, 6, 7. So typically I would let you do this on your own in class and whatever method you want, but well, that's not going to work. So let's do I, J, K, I, J. So we have 2, 3, 4, 2, 3, 5, 6, 7, 5, 6. So this cross product 2, 3, 4 crossed 5, 6, 7 is equal to 3 times 7 minus 4 times 6, then for y, 4 times 5 minus 2 times 7, 2 times 6 minus 3 times 5. And so this is equal to minus 3, 6, minus 3. And also you should, on your own, what is 5, 6, 7 crossed with 2, 3, 4? All right, so that is how you do a cross product. And you can see that the final direction is encapsulated within here. This is a very useful way if you've got a setup where you've got, so we'd been looking at things that were just in 2 planes. If you've got something in 3 planes, a cross product is clearly going to be a lot easier than trying to do a right-hand rule in 3 dimensions. In terms of when to use what, I mean, look at your problem setup. You're often directed by the information you're given for which one's going to be easier. So you can, if you're given 2 magnitudes and an angle, it's going to be pretty straightforward that you're looking at a magnitude and then finding a direction using the right-hand rule. If you're given vectors, then you're very clearly being set up to do a cross product. If you find, so I will admit, I tend to think like I really like doing cross products over looking at magnitudes and finding directions. So I have been known to convert things into vectors, not in class, but in my own work. And I definitely did that when I was a physics student. I just found that to be easier. But I don't represent all students. And this is one of those areas where I really encourage you, find what works for you, what makes sense. As long as it's still accurate from a physics perspective, there's more than one right way to think about this. So next semester, you're going to see a lot more cross products. You're going to find some people really gravitate towards the right-hand rule for verifying directions. And then you'll find that there'll be some people that really gravitate towards understanding and knowing cross products for verifying directions. They're both fine ways to do this. And one is not more right or more wrong than the other. It just more gives you information about how your brain works, how you reason through things. And when we have complicated problems, like the problems that we are trying to solve as physicists and mathematicians, we need people who think in different ways. So that is my spiel there for how to understand that. So let's move on. So now we can write out translational, angular momentum, and then instead of saying relative to the sun, we'll just do relative to some point, we'll call it A. So translational angular momentum relative to whatever point it is, A, is equal to RA, that's going to be the distance between A and where you are, cross P. L translational with respect to A is equal to RY PZ minus RZ PY RZ PX minus RX PZ RX PY minus RY PX. So that is the cross product formulation. It's a bit to memorize. This is why I recommend IJK. It's also really easy to write down wrong, which is why I still recommend IJK. Unless you've done a lot of cross products and you kind of just have this second nature. The magnitude of L translational with respect to A is equal to R times the magnitude of momentum times sine theta of the angle between them, and you can find the direction using the right-hand rule. Okay, so I want to give you a couple standard conventions because you're going to see them. If you have something in minus z, you'll often see something like this. That means it's going into the page. This has to do with the idea of thinking about vectors being arrows. So arrows have feathers on them. So this is, you're seeing the tail end of the feather. Those are the feathers that you're seeing, and they're going away from you. So if an arrow is going away from you, all you can see are those 4 feathers. Now, I should draw you here, all you would see that. All right, and positive Z, the standard convention looks like this. This is out of the page. You can think about it as, once again, if you have an arrow coming towards you, you should probably run and not look at it. But you would just see the point of the arrow. So that means by coming out of the page. All right, so next up I have an example, but I think I'll actually stop the lecture here, give you some time to really mull over cross products, and we will pick up next time with that example. So I will see you then.